Hello guys. So the project we are going to work on in this video is to detect whether a person has breast cancer in benign or malignant stage. So we are going to use logistic regression in order to detect this. So let's get started. So as you can see in these images, there are two stages of cancer. So one is the benign stage and the another one is the malignant stage. So when the cancer is in benign stage, it's in the starting stage. So when we can start the treatment soon, the person can be saved. If it's in the malignant stage, it becomes more life-threatening. And because of this, this is an important task in important application in machine learning. So we are going to do this by using a supervised learning algorithm called as a logistic regression. So in supervised learning, we give the model the data and also the target it is going to predict. So we call this as binary classification, where the output variable is of two kinds. Here you can see one is 0 and 1. So in our case, it's benign or malignant. So it is an either or case. It can also be like you have to predict whether an image is cat or dog. So you just have two answers and you have to predict this. So let's get started with the coding part. So you don't need to do any installation, just open your Google Drive and open a folder. So I made a folder called breast cancer. Right click there, go to more, and if you are working on for the first time, go to connect more apps to connect the Google Collaboratory. So in connect more apps, you need to search for Collaboratory. You need to link this to your Google Drive account. Okay, so I'll go ahead and search for Collaboratory. Okay, so you can see here that it's already installed because I have already linked it. Otherwise, you have to click this. So after this, it gets linked to your Google Drive account after getting authentication. Then come back and again go to more. So you can find Google Collaboratory here. So click this. So this takes you to the Google Collaboratory website. So this may take few seconds to load. So this is actually a virtual service, Google's virtual service where we can run our Python machine learning, very much useful for research and learning purposes. Okay, so let's wait for it to come. So yeah, so this is the interface we will be working on. So this is called as the Python notebooks. So you have to go on and connect in the right top right corner. So once it connected, it will show a green tick mark. I'll change the name to breast cancer detection for this notebook. Okay. Yeah, it's connected and you can see how much RAM is allocated there. So it's 10 GB, around 12 GB of RAM and 100 GB of disk space, which is very much enough. So I'll just name it to breast cancer detection with logistic regression. Okay, so let's get started with the coding part. So first we need to import the libraries. So let's import the libraries when we need them. Let's not import all of them in the first place. Okay, so first of all, I'll import numpy as np. So you can name this abbreviation as anything you want. I'll name it as np. It is the convention. And import numpy as np and import sklearn.dataset. Okay, so this is where we are going to get the dataset. We don't need to download it separately. So I'll go ahead and run this. Plus shift plus enter in order to run the current cell and go to the next one. So I'll make this variable called as breast cancer. Okay, so let me comment here, getting the dataset. Okay, so I'll make a variable called as breast cancer. Breast cancer is equal to sklearn dot datasets dot load breast cancer. So if you have any doubt in this, you can go ahead and search this function in Google. So you will get your answers. So yeah, it's loaded into the breast cancer variable. So let me go ahead and search about this data. So let's get some description about it. So I'll search in Kaggle. Okay, so you can make a account in Kaggle. It's very much useful to learn machine learning. So yeah, so here is the dataset. You can see the description. Actually, this is a real world data. The data are real and it's obtained from medical procedures called as fine needle aspiration. You can see in this description here. So what happens is they insert a needle and they take a mass of cells from the breast where it's affected with the scan. They take these cancer cells and they make some observations in that. So you can see there are a lot of features. There are malignant and benign, which is represented as M and B. So these are these features: radius, textures, and perimeter. And there is actually 30 features that are made from this 10 basic features. So you can see here there are 357 benign and 212 malignant cases. So we'll be using these features to classify the breast cancer into benign, or the person has the breast cancer in a malignant stage. Okay, so this is about the data set. Let me go again to the collab. Okay, so let's go ahead and print this data set and see. So print breast cancer. So you can see, so this is the data set we have loaded here. So you can see that it is represented as data, where it contains all the observed values from that tests. Okay, so and down there is this target, so which has this 0 or 1 values here. 0 is for malignant and 1 is for benign. This is what we call as labels. Okay, so 0 and 1 are the labels for malignant and benign case. So these are this mean smoothness, mean compactness, mean compactivity. These are the features we are going to be using here. Okay, so what we will do now is, let's get this data and the labels separately. Let me get the data in X. Okay, so how we will be doing is X is equal to breast cancer dot data, and Y is equal to breast cancer dot target. So you can see here it is represented by the variable name target. So we need to specify it here. Y is equal to breast cancer dot target. So go ahead and press Shift plus Enter. Okay. So let's print this X and Y and see whether it has loaded correctly. So as you can see, we have extracted this test data and the labels for it. So in this, we will be using our operations to detect this breast cancer. Okay. Let me go ahead and print the shape of this X and Y, so that we can check how many what should I say, how many data instances or examples we have for training. Okay, so this is done by print X dot shape, Y dot shape. So you can see here it consists of 569 examples. We will be training in this 569 examples, and 30 represents 30 features. I mean, it's 30 columns we will be using. Okay. So now we need to import this data set to pandas data frame. So pandas data frame is very much helpful in order to manipulate the data, to do some operations in data. Okay, so let's go ahead and import it in data frame. Okay, this is done by first of all we need to import pandas as PD. Okay, let's import this to the data frame. Data is the variable to which we will be storing. So PD dot data frame, specify the data, which is breast cancer dot data. Okay, and the columns should be the feature names. Okay, so breast cancer dot feature names. So this feature names was specified in that data we got from the scalar. So these are nothing but this mean radius, mean smoothness, and all the things. Okay, so data class, let's add this target to this class column. So data class is equal to breast cancer dot target. So it adds that label to this data frame. Okay, let's print the sample of this data frame to look how this looks like. So you can see here the first 5 instances are represented here, and in the top row it specifies the feature names. So it consists of 30 columns, and the class represents a label. Okay, which is 0 or 1. So let's now understand the statistics of this data a bit. So data dot describe. Okay, this gives the statistical values of this, which means the standard deviation, mean, and other things. 25, these are percentile, 25 percentile, 50 percentile, and 75 percentile. 25 percentile means, I mean, 25 percentage of the data has the value at 11.7 in this case. So that kind of percentiles are there. So let's go ahead and print this data. Data, okay. So data, class, and value comes. So this tells us how many data for malignant and how many examples are there for benign case. So you can see for class 1 there are 357 cases which is benign, and for class 0 there are 212 classes, 212 examples which is malignant. So let's understand what 0 and 1 is. Okay, so print breast cancer dot target names. So you can see here the target names is specified, that's why we are using target names. So it will show, okay, so malignant and benign. Okay, now we need to find the mean value of for benign as well as the malignant stage. So you will understand once it's done. Okay, we are getting the mean value for both the classes. So you can see here for class 0, which is malignant, there are these data, and for class 1 the same data is there, which is for benign. You can see that for malignant the value is high. I mean, these are the values of the cell radius. So the radius values and other things are high in the case of malignant, and it is low for benign stage. So this is the difference, key difference we'll be using in order to classify the whether the cancer is in benign or malignant stage. So this is one of the important factor you need to keep in your mind. Okay, so as we understood from here, 0 is for malignant and 1 is for benign, because in Kaggle also they have specified that for malignant there is 257, 212 cases, and we got that there. For 0 it has 212 cases, so it is clear. Now let's split the data into train and test set, because we need to train the data and then need to check how it is performing. So we have to check the accuracy of the performance of this model. So hence we need to split the data set into training data and testing data. So let me import train test split function from sklearn.model selection. Okay, so from sklearn.model selection import train test split. So this is the function that splits the data automatically into train and test test data. So we need to specify some parameters here. Let's see what are they. Okay, so xtrain, in xtrain we will be getting the training data, and xtest is the testing data. Okay, the model will be trained on training data. So ytrain is the label for training data, and ytest is the label for testing data. So label are nothing but 0 and 1. So we have to specify this function train test split. So you need to specify the data which is x and y. We have already, so you can see here, we got this data here as x and y. Okay, so this is x and the label is y. So we need to specify that here. Okay, let's go ahead and run this. So it is split, but there are certain things we need to keep in mind. Let's see how many instances are there for training and how many instances are there for testing. Okay, so I'll go ahead and print the shape of y train and y test. So it shows us how many examples are there for each cases. So as you can see, 569 total examples are there. 426 are for training and 143 are for testing. So we don't need that many testing data. We need as much more of training data. So we may need only 10% of the total data as testing data. So we need to specify that I need only 10% as a test data. So we need to specify that here. Xtrain, xtest. It's similar to what we have done before for train test split. So xtrain, xtest, ytrain, ytest is equal to train test split x comma y. So the parameter used to specify this is test size is equal to 0.1. So 0.1 represent 10% of test data is required. So I'll run this, and now we shall check the shape. I mean, we shall check again how many test data we got here. Okay, I'll copy this and print it here. Okay, you can see here that 10%, around 10%, that is 57 test data we have acquired from the total data. So that's enough for us. So now what we need to do is, let's see, I'm printing the mean value. So why I'm doing this is the mean should be similar for the original data, the training data, and test data. So only then it is means that the data is similar to the original data. Because let's say that the malignant and benign cases are not equally distributed as in the original data. You can see that there is a difference in the mean of Y test. Okay, so these three means should be almost equal. Okay, so for that we are going to be specifying this parameter called as stratify. Okay, so explain, it is similar to train test split. We just need to include the parameter called as stratify. To train test split. Test size, let that be 0.1. So if you want 20%, you can go on and put a 0.2. So stratify, we are going to stratify based on Y, which means based on the labels as 0 and 1. So for equal distribution should be there for 0 and 1. So let me go ahead and print the mean again. So see whether it has split well. So now you can see that the mean is almost similar. It's a very small variable there. So it is almost similar. So this is what we want. Okay. Now what we will do is we will include another parameters called as random state. Let's say you want to split the data the same way I did. So for that you need a specific number. Okay. Um, let's say x train x test y train do y split is equal to train test split. The other things are same. So why this is if you want to split the data the same way as I did, you need to specify the same number I gave for random split, a random state. So if you this is useful to reproduce the code, so that the data is split in the same way. So I'll specify here stratify is the same as equal to y, and random state is equal to 2 is equal to 1. Let me put 1 here. If you put random set is equal to 1 when you are doing this coding part, it will split the data in the same way. If you put 2, it does that in the same way. It needs to be like, if you want to replicate the code exactly as you want, you need to specify the random set. So I'll go ahead and make comment of what this parameters are. So test size is to specify the percentage of test data we need. It's always good to comment your code so you can understand what it really means, and also others who are seeing your code can understand what it means. So stratify is to split the data correctly. Okay, stratify for correct distribution of data as of the original data. Now random state. You can go ahead and give any random state or test size you want. It's up to you. You just go on and play with this and see what's the difference it's making. So it's a specific split of data. So each integer value has a specific splitting of data. Okay, so this is done. Okay, so but when we print the mean value of x test and x train, it won't be similar because they have 30 features and it differs for each features. So I'll just show you that it's somewhat different, and it doesn't require, because we just need the y value should be distributed equally. So there may be some difference in this x mean, so it's not a problem there. So as you can see here, it's there is some difference, but it's completely fine. Okay, you just need to be y mean to be similar for y train and y test, which we have already checked. So that is fine. Okay, let's go to our next step. Okay, so let me run that again. Yeah, you can see. So there is a difference, but that's completely fine. So let me print and see the X train. So yeah, so these are the data. There are actually about the 450 data, but we can't see everything there. So okay, so let's go ahead and make our model. So as I said earlier, we are going to use logistic regression, and the logistic regression is an important supervised learning algorithm, and it is the best for binary classification problem. We are using this because our project currently is also a binary classification problem. So you can see here, as I already showed you the logistic regression. So let's see what exactly the formula behind the logistic regression. Actually, logistic regression is a sigmoid function. So so this is the formula. So where x represents the input features we are going to give, and p represents the probability which gives 0 or 1. So let's go ahead and see this function. So actually it's a sigmoid function. That is a really good working function. If, as you can see here, one class of data falls in one side of this sigmoid curve, and the other class falls in the another curve. So let's go ahead and make this logistic regression model. So you don't need to understand every math behind it. So there are ready-made codes available in sklearn, so you can use it. So it's not that much important to understand every math behind it. If you want to understand, it's really good if you want to do some research works. So otherwise, you just need to know how you have to implement these functions. Okay, so let's import logistic regression from sklearn. From sklearn dot linear model, import logistic regression. So the upper and lower cases are important here. Okay, so you just need to keep it in mind. So let me import logistic regression. So it is a ready-made logistic regression code is available. So if you can also develop it from scratch, but it's actually time consuming. So okay, so let's load this logistic regression to a variable called as classifier. So classifier is equal to logistic regression. So you need to specify this parenthesis. Okay, so we are loading this logistic regression to classifier. So now what we have to do is we have to fit this data set to this classifier, which is the logistic regression model. So this is what we called as the training part. Okay, so we need to do training on this logistic regression model using the training data we have got here. So I have loaded the logistic regression to the variable called as classifier. So let's begin our training part. Okay, so training the model on training data. So we have split the data correctly as X train, X test, and Y train and Y test. So classifier dot fit. Okay, so classifier dot fit. You need to specify the training data and the training label, which is X train, and Y train, which is the label for X train, which consists of 0 and 1, whether it's malignant or benign. So if you don't understand how this function works, you can go ahead and put classify.fit and question mark and run this. So you will get this help section where the description of this function will be there. You can also go ahead and search it in Google. So you can see that X and Y. X represents the training data and Y represents the labels. So we have given the data and the label here. Okay, I'll go ahead and run this. So once this is done, yeah, the model is trained with the training data we have given. Okay, so now we have to check how our model is working. We need to check the accuracy of how our model works. Okay, so let's go and evaluate it. So evaluation of the model. So there are functions in sklearn to in order to run this. So we need to import accuracy score from sklearn. So this is one of the evaluation methods for the logistic regression models. So from sklearn dot metrics import accuracy score. So let's do two kinds of evaluation. At first, let's evaluate on how the model works on the training data. Then we can check how the model works on the test data. Okay, so prediction is equal to, I'll name this variable as prediction on training data. If you don't understand the function accuracy score, you can Google it and see what it means. So classify.predict function predicts the label for X train. Okay, we are not giving the label here. You can see here. So the model is already trained, and now we are checking the model by giving only the X train. So we are predicting X train, getting the accuracy score here. So to check the accuracy score, you need to give the original answer, original target value, and the prediction that the model is going to make. So the accuracy score compares both of them and gives the percentage of how much data it can predict correctly. Okay, so let's go ahead and run this. Okay, so now it makes the prediction. Now we shall go ahead and print this accuracy. So how much accurate our model works. So accuracy on training data. Okay, so let's print it. So I'll rename it to accuracy on training data. So let's copy it and paste it here. So go ahead and run this. Just press shift plus enter. Okay, so you can see that it's 0.95, which is 95%, which is amazing for the amazing performance of the model. So but we need to check this for test data as well, because the model already saw the training data but it haven't seen the test data. So we need to check the accuracy on test data. So finding the accuracy for test data is the important part in the evaluation of the model. So let's make the prediction on test data. So prediction on test data, let's name the variable as prediction on test data. Classifier.predict. So let's put X test here. You can see that before we put X train, now we have to put X test here. So let's find the accuracy on test data. So accuracy on test data is equal to accuracy score so you need to give the original answers, which is Y test, and the prediction the model has made, which is prediction on test data. So the accuracy score compares the correct answers with the ones our model has predicted. So you can go ahead and run this. So now let's print the accuracy for test data. Okay, let's copy it from here. Generally, the accuracy on test data will be less than the training data, so it's not a bad thing actually. So let's find the accuracy test data. So zero point 0.9 to almost 0.93, which is 93%, which is amazing for a test data predictions. So we got this 95% of training data and a 93% for a testing data, which is amazing. So our model works just fine. Okay, so you can also go ahead and check this with other models and see which has the better accuracy score. So now what we will do is we will give a new instance to our model and check how it's predicting. Okay, so we can print the type of cancer, I mean the which stage of cancer the person is in. So detecting whether the patient has benign or malignant stage cancer. Okay, so for this we need to give the input data, which are the observations we got from the finite needle analysis test. Okay, so detecting whether the patient has breast cancer in malignant or benign stage. So let's make a variable called as input data. So we need to give all those feature values here. So I'll go ahead and download the data from Kaggle. It's a very small file. You need to have a Kaggle account. So you have to go and sign up here. So I'll just search it here. Breast cancer dataset Kaggle. So I have already have an account. So you need to sign up for an account, a simple procedure. So then you can download the data from here. Just download the data correctly. I'll also upload the materials in the course details. Okay, so this is where you need to download the data. So this is the data we worked on. So go ahead and download this. It is the same as the data we downloaded, we imported from sklearn. So let me get this data. So I'll rename it to breastcancer.csv. So it basically consists of comma separated values. Okay, so let's open this in Notepad. So we need to put this, let's find the case, malignant case. So we need to copy this input, I mean these feature values, which are our input. The output will be benign or malignant, which is 0 or 1. So I'll go ahead and paste this input values here. Okay, so actually these are for malignant cases. Let's see whether our model predicts it correctly. So we need to change it. Actually it is a tuple. Okay, so we need to change this tuple to numpy arrays. So numpy arrays are better for operations. So let's change the input data to numpy array in order to make prediction. So input data is equal to input data as numpy array is equal to np.asArray. The function asArray converts this tuple to array. Okay, so that's why we are using this function. You need to specify the array here. So the tuple here, which is input data. Let's also print this and see. Then what we will do is we need to reshape this because we are predicting for a single instance. So we need to reshape the array. Just do as I am doing, so you will get the outputs correctly. So it should be in correct shape. The matrix should be in correct shape. So that's why we are doing this part. So this is done by the function reshape. Okay, so input data reshaped. So input data, okay, input data as numpy array dot reshape. So it should be 1 comma minus 1. So 1 comma minus 1 should be used when you are predicting for a single instance. So that is the rule there. So it should be 1 comma minus 1. The shape of the matrix should be. Now let's make the prediction. So prediction is equal to classify dot predict, because we have imported the logistic regression model to the classifier variable. Okay, let's go ahead and predict the output for this set of values. Prediction is equal to classify dot predict input data reshaped. So this is the input to the model. Now it should predict whether it has it gives 0 or 1, which means it the cancer is in benign stage or malignant stage. So as we have this model, if a new patient comes and if we makes them to go do the finite needle analysis test, from this data we can predict whether the person has which stage of cancer. Okay, so I'll predict this print this prediction. Actually it returns a list with element 0 or 1. Okay, so if 0 it means malignant, if 1 it means benign. Okay, so we need to get this 0 or 1 from this list. So the variable prediction is actually a list which consists of one element as a 0 or 1. So let me comment here. So if the list is of 0, it should be malignant. If it is 1, it should be benign. So let's make a simple if condition to just name the labels. Okay, so if the prediction is a list which contains 0, so prediction, so I'm just specifying the element here, so that's why the 0 is used to extract the first element of the list. Okay, so if the first element is equal to 0, then you have to print that the cancer is in malignant stage. Okay, so if this is not the case, if the prediction is a list which contains 1 as its element, the cancer is in benign stage. So that's the idea behind it. Okay, so if prediction is equal to 0, we have to print that the cancer is malignant, and else we have to print that the breast cancer is benign. So then the treatment can be started quickly and a person can be saved. So hence this is a critical machine learning application. Okay, let's go ahead and run this and see whether it's predicting correctly. So yeah, you can see the list here which contains 0. So hence we are printing the breast cancer is malignant. Okay, so it's actually correct because we have got the input data from malignant. You can see the M next to the data there. So now let's check for benign case. Okay, so you can see here it's B represents benign. Let's copy this data and print it in the place where we put it the malignant data before. So now it should predict that it's a benign. So if it predicts correctly, it works just fine. Okay, so I'm pasting it here. So and then run this again. So now you can see here the list contains a value 1, which means we can print that the cancer is in benign stage, which is correct from here. Okay, so as you can see, we have predicted this correctly. So our model works just fine. Hence, logistic regression works really well for binary classification problems. So I hope you have understood this. So let's what we do is we shall just see a quick recap of what are the things we have done. So first of all, we are importing the libraries numpy and sklearn.datasets. We are getting the breast cancer.dataset from sklearn, and then we are printing the dataset here. So these are the observation values. These are the labels of whether the person has benign stage or malignant stage cancer. So we are getting the data as X and the labels as Y, and we are printing the shape and finding how many data are there. Then we are importing it to the pandas data frame. So we are just making a class column called a class, and we are just printing the sample values in the data frame. So next part is some statistical values. So this is not that much important in this case, so but it will be needed for some other application. So that's why I wanted to introduce you to this. So you can see how many examples are there for class 1 and class 0. So we are just finding the mean values of benign and malignant stage. So for malignant stage cancer, the size of the cells are quite big when compared to the benign stage cancer. So that is the difference, which is very much important for this classification. So now we are uh, splitting the data set. So we are splitting it based on the test size we need it to, and then we are stratifying it based on the Y, so that the data is split in a correct way. Okay, then we are making a random state for a specific split of data. You can put any state you want. Okay, so I'm just printing this explain. Now the most important part where we introduce the model here. So we are importing the logistic regression model to a variable called the classifier, and we are fitting the data X train to the classifier, which is the logistic regression model. So the model is trained with the data, and now we are making the evaluation. We are finding the accuracy score on training data and the test data, to check how the model performs on training data and the test data. So we found this the accuracy is pretty good, which is 95%, which means for 100 examples the model can predict 95 examples correctly, so which is very much huge. So it works almost accurately, which is really great. And next what we are doing is we are predicting by giving the input and output whether the cancer is in benign or a malignant stage. So I hope you have understood it. So now let me give you a task, let me give you a challenge. What you do is do this code, but don't use logistic regression. uh, search for yourself and see how you can use k nearest neighbors algorithm in order to predict the you can in order to classify the breast cancer into benign or malignant, and check the accuracy score between logistic regression and k means clustering. Okay, so every part is same except the model you're importing. Okay, so predict this by using k nearest neighbors. So this is the challenge I am giving you. So it will be fun to work this on and compare the accuracy score here. That's the main task you have. So predict this by using k nearest neighbor algorithm and compare the accuracy score for logistic regression and k nearest neighbors. Okay, so I hope you have understood the idea behind this project. So this is one of the classic machine learning examples which is done on real world data, which is very much important. So I hope has been a good learning experience for you. So go ahead and run the code for yourselves. Okay, so I'll see you in the next video. Thanks, bye.